Welcome to RedTeamTP. Generate, commit, and deploy offensive infrastructure using GitHub Actions. My name is Alex Martirosyan. I'm one of the lead penetration testers for the DenSecure group by Wolf & Company. We have a booth back past the main stage. Please come grab our swag. We really don't want to send it back. So if you haven't stopped by, please do. We have backdoors and breaches decks and all sorts of fun stuff to take home. So yeah, looking forward to meeting you and now getting into Red Team TP. Before I jump in, there's going to be two components to this talk. One is me just going through some slides, motivating why I decided to build Red Team TP on top of an existing project called Warhorse. For those unfamiliar, Warhorse is a Terraform Ansible generator. It was created by Ralph May. He also has a booth back there and works for a new company that is developing Arrow and Spear. So highly recommend going to their booth as well. They're right next to us. So please stop by and give him my kudos to him. But the first component, like I mentioned, we'll be going through just some slides motivating what RedTeamTP is all about, what infrastructure as code actually is, and why I decided that there needs to be a way to automate infrastructure management, especially for offensive operations. There's a lot of complexity that goes into managing offensive infrastructure, especially for a consultancy. If anyone, how many, just show of hands, how many people work on a red team or do penetration testing at any capacity? Okay, so really just the middle section right here. Those with the hands raised, they're going to know that deploying a phishing server, a Cobalt Strike C2 team server is really complicated and takes a lot of manual effort. And without the use of Terraform scripts or automating that infrastructure, you could spend manual hours dedicated to building out infrastructure instead of testing. That's a brief problem statement that motivated me to try and figure out how can we develop something that takes away being an infrastructure wizard or an expert and allows different operators in a team to actually utilize these tools in a meaningful way and worry more about testing and providing value to their customers rather than worrying about manually tweaking things, burning their infrastructure to the ground, due to OPSEC safety concerns, etc. The second component of the talk itself, I'll walk through the tool as well. There's a lot of code, obviously, so I'll do my best to share the screen. The tool itself is now released. So initially it was private just because I was still testing it and somewhat still in a beta stage. So hopefully what you can get out of this understanding, at least from a defensive perspective, what offensive practitioners and threat actors need to do to develop capabilities and resources. And if you're on the red team or pen test side, the project exists now and you could use it internally, hopefully, to help save a lot of time. So I'll walk through some of the code, show you an example of a deployment, really walk through the actual technical details of how it all works and the time it took for me to figure out how to update Warhorse and all the fun stuff in the background. In terms of an agenda, I've structured the slides in three various ways: generate, commit, deploy, the same as the talk, where we'll talk, again, the motivation, the problem statement that I just mentioned, what the tool actually does, and how does deploying or tearing down infrastructure actually look at GitHub Actions with RedTeamTP. So the project itself was created by myself and also one of my good friends. He's a senior software engineer. His name's Artur Sarajan. He's not here, but he was really the architect and actual programmer that knew how to develop and make sure he's leading me in the right way. Apart from my experience as limited as scripting and using Python as a basic penetration tester, I'm not by any means a senior architect designer or know the inner workings of how products should be maintained. He was really a good help for me to understand why we should be implementing the technology the way we are, or how the script should be running, making critical design choices so that way it could scale. Because oftentimes, which I'll get into a different problem in our industry, especially for offensive security, we've stopped sharing a lot of public resources because it's now a competitive advantage for many offensive teams and consultancies to hide what they do and what they know. And then two, a lot of the projects that are open source are pretty much at the scale of just a proof of concept. You can't really scale them, and even if you want to, you need to extend them usually. They're not really meant for long-term projects, and especially the ones I oftentimes see related to infrastructure management. So if you want to deploy a phishing server or you need a team server using Cobalt Strike, Mythic, or Sliver. Usually those are just static Terraform scripts that get stale really quickly. And you ultimately deploy the same thing over and over again, which is counterintuitive from an offensive perspective, which we'll get into just a little bit. If you want the TLDR and just want to look at the code, the GitHub link is right there. It's in our Cornholio. I'm a huge Beavis and Butthead fan, so you'll find some of those references in the code. But if you want to jump in, the link is live. The tool is public now. So what are we actually talking about for people that don't know? The tactic or technique here that we're talking about is acquiring infrastructure, the ability to build it out. When I first started as a penetration tester, you could run MS-1701 and get a shell. You could load a Metasploit, download a public exploit. Everyone was sharing everything, and you get shells all over the place. You didn't really have to worry about EDRs. It was a different time, at least when I first started. But as defenders have caught up, mainly from both an endpoint perspective and enhancing their controls, developing capabilities is now, in my opinion, where offensive security is going to extend to. And being able to do that in a repeatable and efficient way is really important. And you find that oftentimes with threat actors doing a lot of OPSEC failures of leaving open directories. You can go to Shodan, for instance, or Census and start looking at team servers based on maybe a red team just by accident didn't update the certificate and is using default certs or is exposing their directory with all their offensive tools. It's pretty rich to kind of examine and explore. And that's all the purpose of why I figured that there needs to be at least something out there to motivate. This is how you should actually be building infrastructure in a repeatable and safe way, rather than worry about learning all the technical details, which are very important, but not usually for an operator in the day-to-day need to know everything. So we'll be going through actually orchestrating and using Terraform and Ansible. That's really the infrastructure as code in the background of how RedTeamTP was developed. So the actual purpose. So like I mentioned, when I was examining other projects, there's numerous projects that offensive security practitioners, they kind of reinvent the wheel continuously. And one of the design goals that I had with this was it should be scalable, easy to use in terms of a platform. There should be kind of either a web interface or something that an operator can kind of quickly go to. They don't need to pull down a tool or install these sorts of dependencies. They should just be kind of existing in this environment or application to deploy what they want. So I decided to use GitHub Actions for that just because it's really powerful. One of the constraints of the tool, so if anyone's in the code or starts looking at it, it's a little bit unique because it's a project. The repository itself is pretty much a project. It's kind of a proof of concept you can think of it as, which is unique because there was no easy way for us to package it. So it's not like as if you could go to pip and install a package and now you have RedTeamTP. The repo itself is really the project because the benefit of using it is that all the workflows, it's self-contained. Actions itself allows you to have a containerized runner to be able to deploy and not rely on downloading dependencies or worrying about the code or the workflows. While I highly urge urge you to explore and understand the code, you don't need to be an expert and kind of download all these different dependencies and tools to be able to leverage it. So GitHub Actions is a really important component of this because that's where the workflow sits. That's how you actually ultimately deploy infrastructure. And part of that, I wanted to make it a collaborative environment because I wanted to actually use it for our team internally. Because the problem that I was running into is that individuals on my team, they would come to me to essentially deploy their infrastructure. So I'd have to spend time of deploying EvilGenX if I want a phishing server to capture credentials for a phishing campaign, or if we need a new command and control server listening, it would take time to kind of deploy that in a meaningful way. And how do we iterate that and actually make it collaborative? So that way, if I deploy something, an operator can then learn from the configuration that I deployed. There's a PR where there's a commit, you could look at the history, and not everyone can kind of build on that foundational experience rather than me training one person. That knowledge transfer is now completely lost. So the three components of RedTeamTP, it's going to be Terraform, Ansible, and GitHub. And again, the GitHub repo is pretty much a project in itself. And I'll get to some of the constraints and the uniqueness of how you can actually leverage it. So the development process, I mentioned some of this already, at least from a problem set perspective. Whenever we're developing tooling, and at least from an offensive perspective, we aren't software engineers by nature, right? We're not developing or designing these massive programs that are going to be scalable. We're really just doing proof of concepts usually, or just showcasing some sort of cool technique, but they're not meant to be these kind of long scale solutions that serve in an industry. So I wanted to at least publicize that because that's obviously something that maybe offensive teams have internally, but I didn't really see an open project that was transparent and in nature and at least describing how this all works. I also wanted to make sure that there was that thinking at least of how we're actually going to scale this, because my hope is that once I release this tool, if someone starts to use it, they should be able to extend it pretty quickly of, hey, there's this new role, we want to make a redirector or a different use case for deploying various sets of infrastructure, because the ones that I have are templated out are pretty much just phishing and some C2 servers. But my hope is that if there's a way, maybe all of us in the community can think of other resources that we are automating. That's the purpose of how we can start developing this tool and make it a little bit more interesting. So yeah, like I mentioned, scalability is a really important constraint to me. And then another one was the reason I chose Warhorse is because years ago, Ralph May, he had a hacker ops course where he was teaching operators and anyone in offensive security how to think and leverage DevOps essentially of how can you use infrastructure as code to deploy and automate infrastructure. And that was an amazing training when I took it. And he released Warhorse a little bit after that fact. So Warhorse, for those unfamiliar, is a different project, but it's responsible for generating these configuration files where you can then automate the use of Terraform and Ansible. And since that project already existed, I didn't want to reinvent the wheel. And I didn't want to just make a brand new project where there's already existing code. The project was pretty well maintained to some extent. Yes, it wasn't updated in several years. Not trying to bash on Ralph, but he just didn't have the time to maintain it. So that was part of my mission set of first, I should probably update Warhorse and how do I actually use it using GitHub Actions and what I learned in this course to make something a little bit more interesting and maybe even more efficient than just downloading a code base, a tool, and having one expert know how to use it. Our DenSecure team, for instance, was relying on Warhorse for quite some time. And we ran into that issue where if you're using a different version of Ansible or Terraform, it wasn't going to work for you. Some of the roles were out of date. We tried to customize it with a Flask app and have a user interface, a web interface, but it just didn't really scale the way I wanted it to. So that's really where these design principles and choices for RedTeamTP actually came from. Another important thing for me was actually creating unit tests. So oftentimes, like I mentioned, we're not software engineers. So we're not testing our software. We're not actually making sure it's reliable and efficient. So if there's a new dependency or something changes in Terraform or Docker changes all of a sudden, your entire application and infrastructure just breaks. So I wanted to make sure that there's at least unit tests and we can easily scale this. So if someone contributes to something, we could test it, make sure it works. And there's a history of at least chaining the type of activity that we're performing. The environment should also be user friendly. So, like I mentioned, I want people to learn and continue understanding what the technology is actually doing. But at least from a specific use case, the core goal was let's deploy infrastructure as efficiently in this automated principle with OPSEC safety in mind, and make it collaborative for offensive teams. So that way, those individuals that don't have that experience can learn from everyone else and contribute maybe later on, and not just have one person or a team of select individuals that are responsible for infrastructure. So the journey for extending Warhorse was pretty long, admittedly. that took time to update quite a bit of code. I linked Warhorse in the bottom here. It's maybe a little bit hard to read on the slides. I'll share the slides as well. So if you want them as well, I'm happy to share them. But Warhorse itself, that's a project on GitHub that you can go there. I forked it essentially. So my fork is up to date with all the testing and a lot of brute forcing to try and figure out what needed to get changed with all the requirements within Ansible, the new versions. Terraform was a little bit wonky at first with the new version I need to use, especially Docker roles and Ansible roles. Those all need to get updated, at least for the use cases that I had in mind. So my first step was updating Warhorse to make sure I could deploy infrastructure using it with up-to-date versions of everything in the background and all its dependencies. And then from there, I could start building off of that to make another generator or this GitHub Actions environment. So what does it actually look like? This is my fork of Warhorse and what RedTeamTP actually uses. You'll see 162 commits. A lot of that is just brute forcing. It's not pretty code. But that was the first effort, at least in extending Warhorse. That was really a core principle here, where I wanted to take something that already existed. It worked really well in the past. The project didn't have as much support as I wanted it to, or I felt it deservedly should have. So that was the first part of it, just updating Warhorse, making sure I could deploy infrastructure because that was already kind of existing. Why do we need to rebuild something or make a new Terraform script when a project that already does that already exists? I then updated the roles. So Ansible roles, those are just responsible for, you could think of it as Terraform is responsible for orchestrating the providers. So in the background, what Terraform does, for those unfamiliar, is it speaks to your cloud providers like DigitalOcean, Amazon Web Services, Azure. And when it does that, it's able to spawn or utilize those resources in the background of services. So in Azure, for instance, Warhorse is going to use the CDN front door and able to provision different domains and CDNs for you. DigitalOcean is really the background of and the core architecture in terms of actually spinning up the servers and where the bucket storage accounts are actually located. AWS also same story. It uses S3 buckets if you want to, and you could leverage other CDNs and CloudFront domains if you want to as well. I then updated Cobalt Strike roles, so Ansible roles. The difference between Terraform and Ansible. Ansible is going to orchestrate and actually design and install the applications, change the operating system the way you actually want to, and install all the Docker containers that you want to deploy as an operator. So if I'm an operator and I want to deploy, I'm on a phishing engagement. Let's just simplify the process here. I have a social engineering assessment that I need to perform. I need EvilGenX to be spun up. I need GoFish. I need my domains with TLS certificates. I maybe need some CDNs as redirectors to ensure that only the targets can actually visit it and could bypass potentially web filters and content filtering. So with that, I can choose all those different technologies and providers, make sure all my Ansible roles are up to date, and deploy that with Warhorse. That's essentially the basic idea. And what you get in return is a server that's automatically, you can grab a cup of coffee, walk away, hit a button, and now you have this phishing server in this consistent format the way you want. You don't have to worry about OPSEC features because they're already implemented. And now you can just worry about actually targeting individuals to gather credentials. So RedTeamTP, the little overview of it itself. The difference between Warhorse and RedTeamTP, although RedTeamTP uses Warhorse, the idea here is, again, the repository is a project. And that what it gives you is the ability to use actions workflows to generate compliant Warhorse configuration files. One of the challenges when I was exploring Warhorse is that I can become an expert for my team to deploy these servers or this offensive infrastructure, but to knowledge transfer that is really difficult because then I would explain you need to install Terraform this way, you need to use Ansible Vault, you need to use this version, but not that one. It just was a convoluted process that I didn't think was necessary. So that goes back of there should be some sort of user friendliness to this application, and that's what RedTeamTP really does. It's a Python-based application that generates these YAML configurations as pull requests in GitHub. So that way, if I'm an operator, I can go into GitHub and all of it's self-contained. You can run an action to generate a configuration file. So like I talked about, you can go through the actual application, spin up the workflow, put in inputs of this is my domain. I want to deploy a phishing server, and I want these types of CDNs to be deployed along with as my redirectors. Once you hit run on that workflow, it generates a configuration file for you. And that configuration file is public to review, at least from the team perspective. So if you have a private repo of RedTeamTP, everyone on the team can see that configuration file. It makes a pull request, meaning that you could review the actual details of what you're deploying before you do it. Make any necessary changes because maybe it's just a template and you want to make a modification to the fishlet that you're going to use for EvilGenX, or you want to make a modification for the domain. Whatever you want to do, that's all within the actual configuration file, which could be edited within GitHub. You don't need to install the tool. You don't need to do any of that. You just go into GitHub, edit on demand, and push the changes to that PR, the pull request. And that provides you with a collaborative environment because the pull requests then get labeled based on what was actually successfully deployed and what wasn't. And that way I can easily track what is actually deployed in my team. Because one of the other challenges is, as an offensive practitioner in a consultancy, I have to then be responsible for engagement A, B, C, and D, and make sure that my team is actually responsibly destroying that infrastructure so we're not paying for it. Is that infrastructure burnt? Does it still exist? Are there credentials stored in there? These are kind of all the constraints and problem sets that these either threat actors or at least us as practitioners go through. So it's important for me to kind of track all the different changes that we're making and make sure I can know that this is when X was deployed. It has a kill date. I can look at the actual configuration that was present and also assist dynamically. So if someone has an issue, I can look at the action output, which we'll get into and visualize this if you're a more visual person. I'll show you exactly what it looks like. So there's no secret here. But the core functionality is in the repo is that it leverages a Python-based application to take basic user input of, I want to deploy a phishing server, I want this domain, and I want this fishlet, right? The basic choices like that. For a C2 server, it'd be kind of similar. I have this domain that I want to use. This is my CDN that I want to deploy with as a redirector. And I want to use this C2 type of Cobalt Strike or Mythic. Those are the supported ones right now. And then actions will take care of the workflow for you. So once you're ready to deploy, you hit another generate deploy workflow, hit run, and the action runner is self-contained. It'll install Warhorse for you, my fork, run through all the dependencies, use all the secrets that are stored in the repository. So that way you don't need to manage secrets. They're just managed within GitHub. So that would include things like AWS credentials that you need for Terraform to actually authenticate, DigitalOcean keys potentially to use the state buckets or whatever you need in the background, and also Azure service controls just to be able to actually use the services within. So if you need a CDN, it could do that as well. So let's talk a little bit more of this generation function or this workflow. I mentioned the secrets. So part of the design, so once you look at the repository or get a chance to review it, since it is public, you would want to first download that code base and probably make a private version. You can't fork it, unfortunately, just because that's one of the constraints here. It's not an application that I can easily package and just send to you. You can treat that project more as a proof of concept so you can extend it internally. But with that capability, or once you have it installed and present, you can input all your secrets and get managed within GitHub Secrets. You can also use an action runner outside of GitHub itself. So if you prefer local runners for whatever reason, if you want to have your own server deploy the infrastructure because you trust it more, that's all available to you. So all of this is self-contained within GitHub, and you can put whatever secrets you want. You can choose the providers that Terraform will use and just simply use the workflows as is. We already talked about the PRs, but yep, the PRs can be modified. It's a team-based approach. You don't need to be an expert to know everything in the details of all the configuration files. And as a proof of concept, I started to use this in my team internally to make sure we could get kind of feedback of, hey, what's missing? What's the next design choice? Does this user input in the workflow actually make sense? And what needs to be maybe modified or extended because of a new change in EvilGenX, a new fishlet, a new Cobalt Strike version that needs to be downloaded a specific way. These are kind of the constraints that we play around with and are responsible for maintaining and updating RedTeamTP. So the benefit of actually using GitHub Actions is that it has very verbose logging. You don't have dependency hell because it's self-contained. It'll install the dependencies for you the way you structure the actual workflow. And it should be as simple as you buy the domain, point the name servers to your provider. In this case, it's going to be DigitalOcean. And once you have the domain, you just run the workflows and you walk away, you grab a coffee, you'll get an email telling you when Dependabot actually had a success or a failure for whatever reason. And if there is an issue, then you can review the verbose logging to figure out, was this an issue with my configuration file? Do I need to look at one that was actually previously deployed successfully? Or what needs to get changed for me to actually deploy this successfully in the background? So what does an example code actually look like? Again, will be a little bit hard to read, and I'm happy to go through the code and just a little bit of the actual project and show you an example. But this is one snippet of the generate workflow that I was talking about. So you can think of a RedTeamTP generates compliant Warhorse configuration files. So what it does is it'll grab your GitHub username. So that whoever was the actor that ran the workflow, it's going to grab your username, and then it's going to grab your secrets token so it knows who you are. Grab your SSH keys because those SSH keys are going to be used to actually access the server. So your username for the server and DigitalOcean that gets deployed is going to be your GitHub actor name. And then it's the same SSH keys that you use internally. And if you notice, I'm storing all the secrets within the workflow in the action space. That way you don't have to input plain text secrets in your project. Everything is designed within the user input. Near the tail end of the second half of the workflow, you'll see where the inputs actually come into the actual application. So bin collide generate, that's the step for the Python-based application. That's going to take the type of a fish, your operation number that you may want to track, the domain name, the time to live, maybe when you want a kill date, your phishing domains, if you have a redirect URL that you want to use where you want the target to be redirected for whatever reason, and then obviously at the end, like I mentioned, the GitHub username and SSH keys. At the end, it'll make a pull request for you automatically, and that pull request is then where you deploy from. So, yep, Action Runner leverages a Python-based application, prepares the YAML file for review, uses your public SSH keys that are stored within GitHub, and uses your GitHub username to then understand that this is what you're actually deploying. So let's get into deploy now. So the workflow is here. This is the deploy workflow, and we created these different bash scripts that are in the repository that are open to review, but there's just different functions in bash that are going to run each step of the workflow. The most important one to know is that, again, we're using Warhorse. So in the actions workspace or container, it's going to download all the dependencies for you. Generate is just a different function within Warhorse. It generates a Warhorse configuration file for you. Does all the vaulting and encryption for passwords and secrets. You pass all the different credentials within GitHub Secrets once again, and then it'll actually deploy all within GitHub Actions. So nowhere you're actually needing to install Terraform yourself. You don't need to install the client Python application. It's all self-contained within GitHub. You can then rerun failed jobs or review the verbose logging. So if you can actually see along the way of what the action ran. So if you run into an issue for whatever reason that a domain was missing, a CDN wasn't deployed successfully, you should have the history all within the verbose logging. And at the end of it, an artifact is generated. That artifact is really just a fancy term of saying it's an archive. And it's important for that because that's actually what then gets destroyed. So outside of actual deployments, you can then have the ability to destroy based on an artifact, and that's all contained within Warhorse. So that artifact gets stored in GitHub Actions. It's again privatized. It's all within the private repository, and you are then able to, at a future date after your operation is complete, hit destroy based on the PR or the pull request that's available on the branch, and automatically it'll run the destroy script based on the artifact, and your infrastructure is magically removed, right? Because we're making dynamic infrastructure choices here. We're not leaving static and still stuff. This is per operation, per engagement, so we have to be quick and efficient. And that was one of the other design principles of I want to make sure who's actually deploying what. I have the capability to do this automatically rather than going through an AWS console and clicking right click to destroy essentially. What happens when you actually deploy it? Well, this is what Warhorse actually looks like. This is the up-to-date one. So if you want to use Warhorse or figure out which one to actually use, I'm using my fork in RedTeamTP, but you can look at the code. But then when you actually log into the server using your GitHub SSH and the private key, you get a bunch of green text showcasing that your containers are up to date. So like I mentioned, the most basic template that I have here is a phishing server. You have EvilGenX 2, the container, Dockerized container that is OPSEC safe. I forked EvilGenX to enforce or input the OPSEC safety features of removing the header. So at least the offensive minded folks here probably are aware that EvilGenX has IOCs. So I removed those. I made sure the J4A or the certificate hash is also up to date. Make sure that other Chrome has safe browsing and smart screening capabilities. Try to work around that as well. That's all in a public fork as well as EvilGenX. But that was one of the design principles as well. Of if we're going to use tools and we're going to actually use this in operation, it needs to be OPSEC safe. So EvilGenX gets a green deployment. GoFish is also installed. So if you want to use that to send phishing emails, you could do that. And it's only accessible based on the IP that you set. So all the infrastructure is hidden behind Nginx. Nginx is acting as your reverse proxy that is able to talk to both GoFish and EvilGenX. That's set up because I don't want open redirectors or directories. If you find my infrastructure, if I tell you my domain, you should not be able to see anything unless I want you to. And Nginx was created with a configuration file to block bad IPs that we know are bots. We can input things like turnstile and other capabilities in the background as well if we really wanted to. But that's really handling the front end, right? Nginx is a reverse proxy and speaking to the other Docker containers in the background where if you're actually a legitimate target, you can access EvilGenX landing page with a fishlet. And then at GoFish, it's really from an admin perspective deal to orchestrate email delivery and phishing campaigns. Outside of that, you have Swag, which does the TLS certificates for you, so you don't need to worry about that. That all gets handled for you, where all you had to do was buy a domain, point your name servers, and run the workflows. So before I dive into the code or an actual example that's tangible and I could show you the actual code base, future work here, it is still quirky. So it's still kind of, I would admit, somewhat of a beta release because sometimes something doesn't deploy correctly or you need to modify one line of a configuration. I did my best to try and release something that is ready for production. So we use it internally today. So if you have questions or you're running through a scenario where you want to use it in your internal teams, I'm happy to answer questions via DM, or if you approach me, I could try and get you to a stage that you're going to use this, especially if it's an issue that you have or want to learn more about. And even if you're not in the offensive space, if you just want to learn how this all works and get quick deployments where if you've ran EvilGenX and instantly get smart screened, this is one way to maybe work around that, where I'll showcase an example of that, of how we get around it. And what I want is to be able to identify other Ansible roles or ways that we can automate other infrastructure. Whenever you're automating something, it's important to be able to first walk and really understand like technical details. So I had to really understand how is EvilGenX deployed or how is it created? What are the IOCs? Do I really understand how EvilGenX works to be able to extend it? That way I can automate it, right? So these automated deployments. It's the same thing as true for GoFish or Cobalt Strike and all these C2 servers. You need to really understand how they work before you can automate them, or the deployment at least of them. And what I hope to do is later identify other ways that we could do that. So if it means maybe making Ansible for Red Elk, maybe want telemetry and logging of the C2 of who's accessing it if it's a blue teamer, or maybe it's making a redirector with a domain reputation or categorization capability where it deploys a website for you. These are all things that don't exist right now, but where I envision that this project can easily be supported because the back end of it is really relying on Warhorse, which is now up to date, and you could start building different roles pretty easily. It's obviously takes some time to get coordinated and understand how it works, but pretty trivial to then use and extend with RedTeamTP in the background and use this kind of collaborative environment that doesn't really have a lot of setup required. So let's get through an actual example. I'm going to blow up my screen just so you can actually see what's going on. So I have two sites here. I'll zoom in just a little bit so everyone can see. So the two sites I have here are two different versions of RedTeamTP. This one's a public version. So if you go to Cult Code Hornial, the organization on GitHub, you'll find the public release of RedTeamTP. And this is the private one that I use within our organization, so Wolf & Co. And I'm showing you the private one mainly as an example. So this is infrastructure that was just deployed yesterday. So I'll walk through how that was done. And I'm doing that just so you can actually understand of how you could leverage it, because unfortunately you can't fork this project, right? So you can't use actions if they're forked. And if you want secrets inputted, you're not going to use a forked repository. So you'd have to pull the code base and upload it yourself, called RedTeamTP, and make it private. Again, that's one of the constraints where it makes it a little bit unique that it's a repo as a project. But here I'll show you the kind of use case of how we actually apply it and actually use it. So I'll first show the actions in terms of actually understanding this. So let's go to the actions example. And you can see the updates here that get created. And I'm going to go first to the generate phishing configuration. Again, this is all contained within RedTeamTP. And you can see other operators are running the generate workflow. They're named appropriately based on the actor that was running it. So other team members you could see when we deployed stuff in the background and testing it. If I click on the generate phishing configuration, anyone on the team could do this. This is a private version, so you won't see this on the public repo. But just as an example, I can click on the action that was successfully ran. It has a checkbox on it, and I can iterate through each of the steps to understand what it did. So here it's a Python, install the dependencies of RedTeamTP. It got my username, fetched the SSH keys. It generated the configuration file using the Python-based application, and you can see exactly how it did that. So in this case, I'll show the input example, but I put in the hackspacecon25.com domain. That's what I bought for this example. I put in the auth domain name. In this case, it's auth.hackspacecon25.com. I wanted to use the following fish domains for Azure CDNs, so hsc-ww, hsc-login, etc. And we'll go through what that actually means in a second. Grabs GitHub username, SSH keys, ready to go. And the most important part is it creates a pull request. And that pull request is then able to be reviewed by any operator. So we'll go back to that pull request example. And I'm happy to show this just because we mask it based on operation number. So we track each operation by an operation number. That way we're not storing any secrets or really anything sensitive. But here is where I can start seeing what's happening in the background for my offensive infrastructure. I can see what's currently deployed, if it ever failed. So there's labels that get automatically pushed out to each of the infrastructure that you're managing. And once I click on the pull request, I'm not merging the pull request, but I can review the details of actually what happened. So the RedTeamTP will report to you automatically when I run that workflow. It'll tell me the operation number. So in this case, I used HSC just for proof of concept. The domain that it deployed, auth.hackspacecon25.com, target domains, and an expiry in terms of when this infrastructure should be destroyed. Obviously, I did it for tomorrow or 2 days from now, just as a proof of concept, but you could extend that date to however you need the operation to actually be existing. You can add comments. So if you want to add reviewers, for instance, I could add members of my team to review this PR, check the configuration, make sure I didn't do anything wrong or made any mistakes. So just as an example, I said, hey, as an example, just to say you can add comments, whatever you need to do. And obviously the most interesting part is the files that get added. And this is what it looks like for the actual configuration file for Warhorse. So like I mentioned, RedTeamTP generates compliant Warhorse configuration files. And this is an example of that. So I'll pull this up just so you can read it. Warhorse has different sections that you can think of it as. It's a YAML file that is structured in a consistent manner. And RedTeamTP will handle that configuration file based on very simple user inputs, which we'll get into. Those user inputs get templated out, so they get changed and they're just variables based on what the script is actually doing or the Python tool. And all the secrets then get managed within GitHub secrets. So you could see I'm instantiating the bucket access key, the secret key, none of that gets stored in the actual configuration file of your pull request. And you can see the domain that I again chose. I'm using DigitalOcean, auth hackspacecon25.com. I'm going to use Nginx as a reverse proxy. The name of the virtual machine is going to be gp-fenrir, using DigitalOcean to deploy. I'm only going to allow the GP admin site, so the GoFish administration page, to this specific IP. You could change that as you want in the configuration. I'm using Azure Edge for the CDN redirectors, and it gets mapped within Nginx, so it knows how to handle and forward that traffic. So that gets deployed automatically for us. I could specify a fishlet that gets templated out. The M35 fishlet is the most up-to-date recent one, so anyone that's familiar with EvoGenX, there's just a recent change within M35 for phishing. I'm using that fishlet here, specifying redirect URLs, different domains, the lure that I want to set up and utilize. And the final stages here is really just the Terraform information that you need. Again, we're using DigitalOcean, so it needs a state bucket name. It matches S3 compliance of AWS bucket storage as well, so it may look familiar to some of you, but that's the core difference here is we're using the DigitalOcean endpoint to store and manage this infrastructure for us. Users here, that's a public key, so that's from my SSH profile, and I make a ZSH profile shell so I can actually access it. I know it's a ton of IU, but that is everything handled within the generate action itself. When I go back to actions, let's zoom out so I can actually select what we're doing. If I just showcase an example, this is what the user input would look like. I'm putting in the operation number. This is just an identifier for what you want to track. I use operation numbers based on a client ID, but you could name it whatever you want. In that case, I used HSC. The domain, like we were talking about, that was the auth.hackspacecon25. You could tag it, not really important, just tagging it. That'll add a tag within DigitalOcean. Time to live, just so everyone's aware of how long this infrastructure is expected to last. The subdomains for your Azure CDN, and then any redirect URL that you want to direct the user after they submit or we don't want them to visit some sort of resource. That's all the operator needs to do to be able to run that workflow that generated the file. So if I apply this to a team member and they don't know anything about Terraform and Ansible, all I need them to do is fill out this form, and they're up and running to deploy pretty advanced and sophisticated phishing infrastructure without being super advanced or in the weeds of knowing how this all works. Now let's get into the actual deploy. So that's to generate workflows where you could generate right now to date Cobalt Strike, Mythic, or phishing. So that's EvilGenX and GoFish as well. Then there's deploy workflows where we have deploy EvilGenX 2 or deploy Cobalt Strike, depending on what you actually want to do. And the important understanding here is that we're deploying based on the pull request. So you'll notice when I run the workflow, I need to choose a branch that was created. In this case, I'm going to use a branch called config-hsc because that's a tag that I actually used. You can see before I had an issue, so I had to make up some modifications. But when you have that checkbox, it means I deployed successfully. And in 17 minutes of total time, it deployed all of that for me. So I deployed, again, GoFish, EvilGenX, Nginx reverse proxy, the CDNs within Azure, downloaded the containers within Docker to get all that running, got the Let's Encrypt certificate, changed the domains. It did that all in 17 minutes. So I can walk away, let the workflow run. I don't need to worry about it. It's consistent. I can review the workflow if I really need to know specific information. So if I see the core workflow step here of run Ansible playbooks of generate and deploy, you can see everything that it's doing. It's running that script to be able to run the Warhorse tool. It's configuring AWS CLI. It's configuring the Azure CLI, right? So it's using the secrets. And again, all the secrets get redacted because it's in GitHub. So you don't have to worry about me leaking anything sensitive here. Running the workflow entirely, you can see all the output of what it's doing. And at the very, very end, when this all gets completed, we could see a nice output near the end. This is pretty massive, so we'll see at the very end if I can get to it. Let's go. Quite a bit of output, obviously, from what Warhorse does. This is all Terraform and Ansible information. I'm just hoping I can get to the bottom just so I can show you deploy success. Deploy success is essentially what we're looking for. Go to the bottom. It's quite a bit. I might just jump to the server because this is like, yeah, it's okay. So what did it do? It ran for 14 minutes of running all the stuff for Ansible and Terraform, and it deployed GP Fenrir OK 184. It skipped some resources that aren't applicable, and everything's good to go, right? There's no failures, which is good. It saves the deployment state and uploads the directory to an artifact. So again, that's a post-deployment step. It's going to label it, telling you with green that it actually deployed successfully. So you don't need to monitor this in any capacity. You don't need to be an expert. Just hit the deploy workflow, get a cup of coffee, come back, and you have a phishing server. It uploads the op directory as well. So when I hit the destroy workflow, I can input the same information. It'll use a GitHub information, that static artifact, and destroy that infrastructure automatically as well. So what does it actually look like? Up and running, right? So this is me just in DigitalOcean logged in as the Almart user. That's my GitHub profile name. You could see what it did as demonstration, right? It says HSC, which is a tag, dash GP dash Fenrir, that's the server name. And in green, again, what services do we have up and running? We have EvilGenX 2, GoFish, Nginx, the reverse proxy, Swag with the Let's Encrypt certificates already handled for us. There's additional subdomains that get added in the background, which I could show you in the Nginx configuration file. But in green, we know that the services are running. And these are all Docker containers. So Docker allows us, as fun as Docker is, it allows us to at least containerize all these services. So that way we don't have these massive applications that are interconnected. They're just doing this one thing of running EvilGenX, exposing the fishlet, and that's it. Nginx is only running as a container and using our configuration file. But I mentioned I use the OPSEC safe version of EvilGenX already because, again, when we're deploying or managing infrastructure, we need to remove IOCs. We need to make sure it's up to date. So let's take a look at what that looks like. We have quite a bit here right now, so I'll attach to it. And we'll do this. So I use Docker to attach to the EvilGenX 2 container. I can look at fishlets that are active. And you can see that the fishlet's already running. And again, this is all what the tool already deployed as. This is not anything I need to modify. I can now customize this as further, right? We can continuously automate and make it more efficient. But now I could look at lures. one. That's my phishing landing page. So if we tick this, and if you notice, it's using the Azure Edge CDN domain. Azure Edge is what you get as a subdomain or actual domain when you use the older front door profile within Azure. And we can put in these host names as subdomains. We could choose what the subdomain actually name is actually going to be utilizing. We could take the link now, and I could go to the phishing page. And this is going to help evade things like Smart Screen. Azure Edge is already TLS cert encrypted or has a certificate valid from Microsoft. It's signed, right? So we can evade Smart Screen, web filtering, content proxies, all from just using RedTeamTP, right? So now we have Azure CDNs hooked into our EvilGenX fishlet. And if I start typing here, for example, it's not going to be valid, but I could say hello HSC. Hopefully it'll capture the post. And you can see at the very top, it captured, we're running EvilGenX 2 in debug mode. So you can see it captured the username up front. If I actually put a valid username, you could see it is using EvilGenX in the background, using the fishlet. It would capture the session cookies for two-factor authentication, capture the plaintext password, right? And that's up and running. So if I send this out as a lure now, if I know I have a target, I now just save myself immense amount of time. Rather than me going into DigitalOcean, clicking server deploy, using an image potentially, running EvilGenX, and making sure it's up and running, going to Azure, making the CDNs, make sure they're matching to my Nginx reverse proxy, because that's also being handled in the background, which I can prove to you as well. All right, so let's go there. It's in the op directory. I go there. Nginx. Right, so everything's a container, but some of the volumes get exposed. We could go to config and check out the config that's in use. Nginx. Config. There we go. So there's a lot outputted here, but this is a configuration file that also gets automatically generated for you. So I don't have to go in and tweak it or make any modifications. The core ones that are actually responsible for handling EvilGenX 2 for the updated EvilGenX 2 fishlet are stored here, right? So this is all pointing or allowing the host header that matches within the Azure CDN to point to Nginx reverse proxy. That host header gets transferred to EvilGenX 2 and is not exposed to the world. You can't get to it unless you have the lure. And you can see how it gets matched, right? Here's all the headers that I put in as user input before my workflow for RedTeamTP. It's using the Let's Encrypt certificate that got generated from Swag. And I have these rules here. You can think of it as these if statements to, if you're a bot, for instance, or I'm blocking IP, just redirect you to office.com. That was a redirect URL that we saw before. Location here, right? So this is all the relevant stuff for Azure CDN and how it handles CDN. If you haven't used CDNs with fishlets, it's not as intuitive as you imagine. I could show you what the fishlet looks like from the automation step. But here you can see it's resolving to the localhost, forwarding all of the proxy set headers, and that's actually how we're able to capture the debug information from traveling to something like hsc-login to Azure Edge.net. Right? We're not using a domain that I spun up. It's actually using Microsoft against itself in some ways. To look at the fishlet, we can go back a directory. Let's go there. EvilGenX 2. Let's go to fishlets. And there's my M365 latest one. And again, my EvilGenX version that got Dockerized, IOCs are removed. If I look at the actual host source code here, if you notice, oftentimes one of the constraints of EvilGenX is that it posts all the JavaScript and the static code, which is an easy indicator for scanners. They'll easily identify that as a phishing server, and you'll get nuked by Smart Screen within less than 24 hours, right? So that obfuscation is already handled for you. You don't need to, you can review it. It's important to know how it works, but that's one of the design choices I made with RedTeamTP of OPSEC safety in mind and deploying with Terraform, right? And Ansible. That's what it looks like in the background. And we can go back and you can see what the fishlet actually looks like as well, right? So this is my fishlet. It's running in the background just to prove that this is the same server. Got deployed from RedTeamTP of those two workflows. Generate a configuration file, approve the PR, it looked good, made any modifications, and then simply run the workflow. In 17 minutes, now we have pretty sophisticated phishing infrastructure that can be used against client environments or as a threat actor. We also use this for Cobalt Strike deployments too. So kind of similar. We use redirectors and cloud-based redirectors a lot. So that'll deploy Cobalt Strike for you as well in kind of similar fashion. It uses AWS in the background. You can choose different choices here, but that's the extendability where we, as operators, can choose based on what we're deploying, either use the Azure provider, AWS provider, DigitalOcean, whatever you want to do. This is kind of the power of the automation step where I've just removed so much manual processes, and now I can help explain, hey, this is how Evil Genetics works. This is how we bypass web filtering controls and technologies, and this is how we make sure that we're doing this in an OPSEC safe way and reliable way that I can then track all my deployments. If I go to DigitalOcean, I can see exactly what got tagged, the time to live, and what all my operators are doing, right? I can manage that in a central fashion of going back to RedTeamTP. So I can look at all the pull requests. Again, the massive output here. So apologies for the verbose logging, but I can then go back to the project, look at the pull requests that got made, review all the actions, and start extending the service. I have a couple minutes left. Does anyone have questions? Does anyone want to see something specific? Has anyone used Terraform before, Ansible? Makes sense, yes. Yep. You have a question?
Yes, I have Terraform. Yeah.
I could show probably the last step is simply the destroy one. So I'll show the inputs just because I want to make sure people understand that. So for example, if I was to deploy, there's really only two inputs that you need. It's a repository that got named, which is, in this case, it was HSC, and I named the operation number. So the two inputs are the same. So if I was to do that again, the generate process, you put the same inputs and you're done, right? You don't need to put anything else beyond that. It's really the core step is the generation step that we try to template out. So that way anyone could use this pretty quickly. And they don't need to be an expert at Warhorse or understanding all these YAML files. They could simply just go in, hey, I want this phishing server configured this way. I know my domain, I know my redirectors need to be, and that's all I want to do. So the inputs are maxed anyways to 10 from GitHub Actions, unfortunately. But here we try to just streamline it so that way it's put the operation number based on what you want to track, the domain. So this case again, auth.hsc, tag it whatever you want. That's within DigitalOcean, so that way you can track any of the tags. The time to live, based on when you want to remove it. Your subdomains, that was tied to both Nginx and also the EvilGenX services. Redirect URL based on where you want people to go if you don't want them to be a victim. And you just hit run, right? So then we could go back, look at the pull requests, and you could see all the infrastructure that got deployed. It gets labeled accordingly in a nice format, with comments and things.
Are you able to extend the TTL just in case?
Yeah. Well, that TTL is kind of fake. It's only really relevant in Cobalt Strike because Cobalt Strike will then put in the profile, and then you have a kill date actually set there. But it won't actually destroy the infrastructure. It's more of just tracking. So it's not as if it'll destroy it at that date. You could make that a feature, but I didn't do that because that could be the reason, right? We may need the operation to extend or whatever the reasoning is. We don't necessarily want to destroy something just because it happens. So yeah. It doesn't actually do anything, but the idea here is that if I close the pull request, it would automatically run the destroy workflow. So I don't need to go into destroy and do more user inputs. You can if you want, but the idea here is once you close a PR, so if I click on one of these, it'll then destroy the infrastructure for me automatically. And it's kind of this nice GUI. I don't need to install a dependency or get to a virtual machine. It's just in GitHub, a private repo. Yeah, good question. Yeah, the kill day thing is only in Cobalt Strike. It just gets added to the profile. I know we're approaching time. Any other questions I can answer? Nothing else? Cool. That's all I really had to share. I don't have anything else, but I hope you explore the project and support Warhorse. So please give a shout out to Ralph May because a lot of this design choices and what he made is built off of that. It's not as if I built all these roles from scratch. I use a lot of what Ralph May already did and what I learned from HackerOps. And then my goal here was then publicize, hey, how do we actually use this infrastructure tool? Like, what does it actually look like? Because a lot of that tradecraft is now privatized. No one's really releasing the tradecraft or like what they're doing in the background. And I wanted to explore of, well, how do we support teams that don't have that capability, or if they need to learn how to use these techniques, they can easily do that from a community resource. Because when I started, it was like that. You could learn everything online. It was public. nobody hid their tradecraft. And unfortunately, that's kind of a dying down industry problem for us. So that's really the motivating factor. And I hope you can explore it. If you have questions about RedTeamTP or if you want to utilize it, always happy to answer a question and give you my insight of what I'm working on and kind of what else we want to extend. But with that, thank you, everyone.